All right, so very good evening, guys. Quickly, let us check the audio once. Quickly, let us check the audio once. All right, so very good evening, guys. Quickly, let us check the audio once. It's working for us. Good one, right? So, this class has been scheduled for today based on your suggestion that it should not be overlapping with your biology session. Right, and it starts at 6 p.m. today by Hersh sir, as I remember. So I've had plans to take it before your biology session, so which is now here, right? So just 1 minute, sir. Okay. Bala says hi, sir. Hi, Bala. How are you? Quick, you are here today as well. Good. Your chapter will get completed today, obviously, from the NCRT as well as the notes perspective. Quickly, in next 1.5 hours, Sunil Pradhan says, I am from Odisha. Hi, Sunil. How are you? I think uh, weather is good in Odisha for now. I am personally from Delhi, so everybody knows how polluted we are for nowadays. But then that is good. Uh, we will quickly start. Yesterday, we had done the entire reading, entire notes were there, which we completed in terms of our this one. What should I say? Notes that we completed for the summary that we prepared for the chapter solutions, class 12, chapter 2, primarily chapter 1 now because solid state is not there. But then, as per in old NCRT, chapter number 2 is what we are talking about today. Today's task is that we will go through the NCRT quickly. All that points that you have to capture, as I mentioned in my last class also, that NCRT reading is something which you cannot escape at all for this one. You cannot escape NCRT reading in chemistry, be it physical, organic, inorganic. NCRT reading is the key that will drive you to success, which is your NEET 2024. Quickly, let us start through it. Since we are reading NCRT, I'll just decrease my size a little today so that the book is more clear. Oh, I think that should be the adequate size when we are reading the NCRT, right? Anyway, so now quickly let us start. Sunil says, I have been watching your lectures. Sunil, thank you so much for it. But definitely you will benefit a lot for your preparation while you do that. It's really helpful and I'm telling you, it will add a lot of value to your, what should I say, to your preparation strategy in your NEET 24. Even if NEET 24 is not your attempt, maybe you're preparing for 25, but then still it's going to add a lot of value. All right, quickly. Sir, exemplar problems also. Bala, today I am taking it as a NCRT review session. The next day I will solve questions from multiple sources. Exemplar also we will refer as a part of the course. NCRT, NCRT exemplar, and then the PYQs and some other important questions also. But today, as per se, the agenda of the class is going through the text of the NCRT, and yes, the questions that we come in between, we solve them right away. This is what the agenda is for the session right now. Right? All right. So now quickly we start the chapter number 2, which is solutions. Chapter number 1 is solid state. We will do that in case it becomes a part of the updated NTA syllabus. All right. Now quick. Let us start quickly here. We are types of solutions, homogeneous and heterogeneous. Now, what are homogeneous solutions? What are heterogeneous solutions? Not a new thing for us per se, if I am not wrong, not a new thing for us per se, but homogeneous solution is something which is made up of two or more than two components. Two or more than two components. But the point is that their properties are uniform. That their properties are uniform throughout the mixture. some things which could be noted right away in the textbook itself. And this textbook notes that what we are making today will be learned and locked for any NEET exam, for any state level medical exam that you want to appear for. Their properties are uniform throughout the mixture. Summary noted, we will move forward. In the same thing, we have two more words which are actually called as your solvent and then your solute. Two words which we commonly refer in solution is solute and solvent. Quick definition that we should always remember, not that difficult indeed. Solute is something in the lesser quantity. Something in the lesser quantity, and solvent rather means present in higher quantity. Present in higher quantity. Remember, this is very, very helpful. Solute and solvent. And then the first word, first useful word I should say that you're getting across now is a binary solution. This is an important word, and binary is something which is consisting of two components. This is very, very important. Binary is something which is consisting of two components, which is consisting of two components, right? Binary solution. Then once we have here, it gives us an example. Says solute and solvent, gas in gas, liquid in gas, solid in gas. Same thing we will do when we are in surface chemistry also. When we talk about emulsions, gel, foam, and there is something which we talk about. But what it wants to tell you here, what the NCRT wants to tell you here is that it could be solvent and solute could be in any phase. Solute and solvent could be same, could be in same or different physical states. This is the summary of this table in just one line. In just one line. That why, what is the point of writing gas in gas, liquid in gas, solid in gas, then gas in solid, liquid in solid? That both your solute and solvent could be in different physical forms. Right? And then we have the first topic which is called as the concentration. We discussed about it yesterday and quickly we will scroll through now. So concentration means I want to depict the strength of the solution. Strength of the solution means more concentrated is the solution, more concentrated is the solution, comma, more concentrated is the solution, comma, more are the number of moles, more are the number of moles present per unit mass or volume, present per unit volume, which we call as molarity, or mass, which is called as molality. Surface chemistry is deleted, sir. Bala says surface chemistry deleted. Ha, I know this here, I know this. Surface chemistry is deleted. Right. Okay, good one. So now when we have here the first concentration term that we did yesterday also is called as mass percentage, which is weight by weight. And I told you weight by weight is my weight upon total weight. As an example, see, it is mass of the component upon total mass of the solution. Right? And since we're talking about the percentage basis, since we're talking about percentage, therefore it is multiplied by 100. right? Now, when we say 10% solution, say now it says 10% solution by weight means a glucose solution by weight means 10 grams of glucose in 100 grams of solution implies 10 gram of glucose in 90 gram of solvent. This is really important. This statement is really important when we discuss the relation between molarity and molality. This is very important. This concept that my solvent is solution minus solute is very important. Okay, very important rather. All right. Now we move forward and then we have mass by volume, similar to what mass by mass is, weight by weight is. So it is like mass of component upon volume of solution, right? And then we have parts per million. Anybody who does not sure, million is 10 to the power 6. 10 lakhs is called 1 million. 10 to the power 6. So how many parts do I have in 1 lakh, in 10 lakhs components is called as ppm. Generally this is used for hardness. For nowadays you will see that the air quality index is very high in Delhi, I should say. So how they define it is that sir, SO2 is say 300 ppm. 300 ppm means parts per million. Means in every 10 to the power 6 particles, there are 300 SO2 particles. So that is how it is defined as its number of parts present in, right, 10 to the power 6 because 1 million is 10 lakhs. All right. Quickly we proceed. The next statement that we have is mole fraction. Very simple. Which was chi A is equal to Na upon Na plus Nb. Okay? Right? And so we have chi A. We did yesterday. Then we have chi B. And then the sum of all the mole fractions present in a solution adds to 0. Sum of all the mole fractions, or we should say sum of the mole fractions, sum of the mole fractions, sum of the mole fractions, sum of the mole fractions of all the components present in the solution of all the components present in the solution adds to unity. Adds to unity. Na plus Nb plus Nc becomes a numerator, and then chi A becomes Na upon Na plus Nb plus Nc. Important this one. Then we have calculate the mole fraction. We will come to the questions, not all to worry about. The next concentration term that I have is molarity. The next concentration term that I have is molarity, and it is defined as the number of moles of solute present in 1 liter of solution. Yes, 1 liter of solution. I told you the differences yesterday also. 1 liter solution, 1 kg solvent. It is very, very important. Very, very, very important. Peter Atkins is a good book. Peter Atkins is a very, very good book, but might not be required as per your syllabus requirement for NEET. It's a very, very good book, but then, this book is generally used for the people who are doing masters in their chemistry or something. Only for the NEET exam per se, not Patkins, Peter Atkins might not be required. You have other text to read it, and that can be referred to. Not immediately you should turn on the books, which strictly, oh God, it is so difficult. Should not happen. So difficult, so difficult. Your text should be so beautiful, so easy. That way, your text should be. Right? So, Peter Atkins is a very, very good book, but for NEET exam per se, might not be required also. Might not be required. Right? I want to study in deep in chemistry. No problem. It's a good book. Peter Atkins is a very, very good book. Not a problem. Okay, then we have molarity. Okay, the same formula. Then we have molality. Then we have molality. The same number of moles of the solute per kg. Per kg of the solvent. Right? Per kg of the solvent. So this is very, very important. Molality is solvent mass. Molarity is volume solution. Very, very important. Then you come down and you have a topic which is called as solubility. But before on to which jump on solubility, let us quickly attempt question number 2.1 and 2.2. These two questions we should attempt right away. But before we do it, I just want to hide myself. I'll increase the length of the question also. But then I'm saying that before we do it, okay, no, I was thinking of something else. But then, okay, question number 1 and 2 unsolved has to be taken care by you for now. Quick, 2.1 and 2.2. Quickly, let us do it. 2.1 and 2.2. Quick, try it out. See, the question language is very clear. The question language is very, very clear. It says calculate the mass percentage of benzene and CCl4 if 22 grams of benzene is dissolved in 122 grams of CCl4. Very, very simple. First question is very simple rather. Second question, okay, 1% of logic, but first question is very simple. Okay, see everybody. Bala, first question done. How it goes is, sir, my mass percentage is mass of a component of, say, benzene. I want to calculate mass percentage of benzene C6H6 means mass of benzene upon total mass of solution. Total mass of the mixture or solution into 100 var into 100 var means mass of benzene is 22 upon total mass is 22 plus 122 144 into 100. This is gonna be my first answer. 22 divided by 144 into 100. Anybody, any doubt? 22 divided by 144 into 100. It's gonna be 15.28 percentage. 15.28 percentage. Right? Done. This question is done. Now, very, 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 very important question number two. Remember, question number two is gem of a question when you do concentration terms because it merges two concepts. It merges two concepts. Right? Now, calculate the mole fraction of benzene in a solution containing 30% by mass in CCl4. Means 30% benzene in CCl4. Means what? 30% mass percentage means 30% mass percentage means 30 grams of benzene in 70 grams of CCl4. Why I am directly writing this? Why I am directly writing this? 30 grams of benzene in, eventually it should be 100 gram of solution. But then out of solution, how much will be CCl4? It's gonna be 70. This is very, very, very important catch. Very important catch. Right? 100 grams of solution. Now, how we do it is that 30 grams of benzene, which is moles of benzene, how much? Because I have to calculate the mole fraction, sir. Moles of benzene gonna be 30 upon C6H6, 78. And then moles of CCl4, how much? 70 upon carbon is 12, 4 chlorines should be 30, 171, 142, 142 plus 12, 154. So moles of benzene, how much? It's 30 upon 78. You get it as 0.385 and 70 by 154, you get it as 0.45. So now my chi of benzene, that is mole fraction of benzene, is gonna be moles of benzene 0.385 divided by 0.45 plus 0.385. And how much that accounts for? Divided by 0.45 plus 0.385. 0. Wait. 0.385 divided by 0.45 plus 0.385. 385. 0.461. 0.461. And that is the answer. Second question, really, really important, but we have to see it. Right? Quickly. Thangjam Shrisai, class 11. Hi Shrisai, how are you? Welcome to the class, mere bache. I don't think you were there in the class yesterday, but since you are here today, we are reading the NCRT for solutions. Yesterday, we had summarized this chapter in terms of our notes, and then we will do it. Right? Quick. Moving forward, we have solubility of a solid in a liquid. Every solid does not dissolve in a green liquid in a given liquid, while sodium chloride and sugar dissolves in water, naphthalene and racine do not. Important when we talk about solubility, we always talk about like dissolves like. In terms of organic solvents dissolve organic solvents dissolve organic compounds. Right? Organic solvents dissolve organic compounds. Similarly, polar ionic solvents dissolve polar compounds. That way. So, like dissolves like. Solomon file good for organic. Probably yes, but not for the exam viewpoint, I should say. Solomon is something beyond what you need for NEET. Same for Peter Atkins also for physical chemistry. But since you're naming these books, I'm telling you, but for NEET per se, it might not be required to be honest. Yeah, moving forward, we talk about at this stage, there's a word that is called as saturated solution. Saturated solution means no more solute can now be dissolved. No more solute can now be dissolved in the solvent. That is, I have come to a saturation, sir. Please, thank you so much. I cannot study more. My mind is saturated. Is a saturated solution wherein, sir, all my empty spaces are filled. Please don't add more salt. Please don't add more solute because now I am saturated. English word, but really important. Really, really important. Right? The solution which is in dynamic equilibrium will dissolve and contains the maximum amount. Thus, the concentration of solute in such a solution is its solubility. Very, 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 very important word. In this case, the concentration is referred to as solubility. Right? Earlier, we have observed that solubility of one substance into another depends on the nature. Now, effect of temperature. I told you yesterday also. When we talk about gases in liquid, when we talk about gases in liquid, comma, gases in liquid, comma, we always remember when we talk about gases in liquid, always remember temperature increases, solubility decreases. This is very important, which we discussed about it yesterday also in the session, that for gases in liquids, higher the temperature, lesser will be the solubility. Very, very important to note that down. And then we will take it up. Higher the temperature, more is the higher the temperature, lesser the solubility. Right? Higher and lesser the solubility. Right? J.D. Lee. Okay, I will not comment on the books for now. It says, in general, if in a nearly saturated solution, the dissolution process is endothermic, uh, delta H solution is greater than 0, solubility should increase. With temperature and if it is isothermic, it should decrease. Please mark it as important, very, very important, very, very important. Just give me 2 minutes of time, and in the meantime, let us quickly solve question number 3. Quickly, let us solve question number 3. Okay, question number 3 we have to solve. So easy. There's a question. I'm so sorry. So can we say solubility of liquid is a function of temperature? So solubility of gas in a liquid is a, and definitely solubility is a function of temperature, no doubt, because the hotter you see, there's amount of sugar that we can dissolve, and if we increase the temperature, more sugar gets dissolved. Absolutely, solubility is a function of temperature, no doubt. No doubt in that. Easy explanation is your name. I don't know the name also. Easy explanation. Question number 3 is what we're going to try now. But then you need a mass of cobalt there, which is your 59. Cobalt's mass in this question has to be taken as 59. You want to call it as cobalt, you have to call it cobalt 1 mole. 1 mole means 59 grams. Only cobalt means 59 U. Quick, right? So question number third, 2 minutes of time before you quickly do it. And then we take up further, which is called as Raoult's law. We will finish this NCRT reading before 6 p.m. That is the target that we have. Quickly, let us do it. Third question in 2 minutes of time. All right, the question is done or not done? Quickly. Question done, not done. Question. Okay, I'm yet to get any answer in the chat box, but not a problem. Calculate the molarity of each of the solution. 30 gram of cobalt nitrate in 4.3 liters. Cobalt nitrate, the main thing we had to calculate was the weight of it, cobalt nitrate. So how do we do that? Cobalt nitrate's weight would be 59 plus NO3 into 2. Nitrogen is 14 plus 48. O3 is 48. 14 plus 48 is, what should I say, 62 into 2, 124, plus 6H2O, 18 6 are 98, right? How much do we get here? 9 plus 4 13, 13 plus 8 21, 2 9 plus 9 18, and then 1, which I get is 281. Just check it out if in case I'm doing mathematically wrong. Any correction, you let me know. 281 is what I'm getting. Right, 30 grams in 4.3 liters. So moles gonna be 30 upon 281. This is my molarity. 30 upon 281 into the volume is 4.3 liters. Since it's in liters, so we divide it by that. That is going to be my molarity. 30 upon 281 into 100. No, not even 100, sorry. 30 upon 281 into 4.3. Right? And then this is how we take it as 30 ml 0.5 H2SO4 diluted to 500 ml. This question is going to be done by M1 V1 is M2 V2. All right. Absolutely fantastic. Okay. Yes, sir. Now we come to pressure. Yes, I told you that as well yesterday. Example of soft drinks. Higher the pressure, more will be the solubility. And that is where the Henry's law comes into picture. That talks about higher the pressure, more will be the solubility. Right? Higher the pressure, comma, more is the solubility of the gas in the liquid. Right, of the gas in the liquid. Now we are here coming down. It says the name that we told about, which is called as Henry's law. Henry was the first to give a quantitative relation between pressure and solubility of a gas, which is called as Henry's law. Right, right. Then we have the solubility of a gas in a liquid is directly proportional. The solubility of a gas in a liquid is directly proportional to the partial pressure of the gas present. Again, the pressure is proportional to the mole fraction. The solubility is proportional to the partial pressure. Probably the same, right? Because the more I am, the more is my partial pressure, the more is my solubility. Right? Simple words. Easier language, it says the mole fraction of a gas in the solution. The easier language, it is now here, and that captures as the mole fraction of the gas in the solution is proportional to the partial pressure of the gas, which means my pressure is proportional to chi, and in that scenario my chi, when I remove the proportionality sign, I get the kh, which is called as Henry's constant. Very, very important. Kh is a gas dependent stuff. A gas dependent means kh is something which is called as different gases have different kh values at the same temperature. Means kh is a constant which is gas specific. Different gases will have different kh. Right? Quickly let us see. It is obvious from equation that the higher the value, the lower is the solubility. This is most important. Very, 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 very important peculiar point captured in the NCRT that we should be doing it. It is obvious from the equation that higher, higher, higher the value of KH, the lower is the solubility of the gas. Higher the value of KH, lower is the solubility. Very, very important. This has been covered in the PYQs also, and this is a probable question in NEET 2024. Very, very important. I'm making the paper also right now. Right? Quickly, let us proceed now. Then we have this question. Henry's laws examples are there. Number one is to increase the solubility of CO2, which I told you about the your aerated rings yesterday. Oh wow, what a bad color to highlight. Okay, not a good color, ma'am. But how do I undo it? I don't know. Undo, undo, undo. Should I erase it? Okay, not a problem. Increase the solubility of CO2, sir. The bottle is sealed under very high pressure, right? The bottle is sealed under very high pressure. And then we have scuba divers who go very inside the deep water surfaces, uh, cope with high concentrations of dissolved gases because you go very deep inside. The pressure is very high. Pressure high, solubility high. Remember, pressure high, solubility high. Just as you go down, these dissolved gases are very high. Remember, the dissolved gases are very, very high. So, how do we take it up? Scuba divers must cope with high concentrations of dissolved gases while breathing air at high pressure. Increased pressure increases the solubility of gases in blood. When the divers come towards the surface, the pressure gradually decreases. There are a lot of gases inside them coming out, all the gases are gone. No, 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 no. This releases the dissolved gases and leads to the formation of bubbles of nitrogen. This condition is called as bends. Very, very important. Very, 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 very important rather. Again, this is also a part of the PYQs that you have. It is there in the exemplar as well. And it is again a probable important question for NEET 24 also. Very, very important. I have Sri Sai saying, sir, will be now I will respond. I am live. Okay, not a problem, sir. Anyways, we're doing NCRT revision. We'll quickly do it. To avoid bends as well, the toxic effects of high concentrations of nitrogen, the tanks used by scuba divers are filled with diluted helium. So it's a mixture of gases that we give them so that suddenly the situation of bends is not happening. There's one more word, anoxia, which is coming now. At high altitudes, that is, we're going at heights now. First, we were going down the water. Now we are going above the mountains, right? The partial pressure of oxygen is less than that at the ground level. Pressure is low. This leads to low concentrations in the bloods and tissues living at high altitudes. Low blood oxygen causes climbers to become weak and unable to think clearly. Remember, if you are a very plain person means you live on plains and suddenly you go to a very, very high altitude, your brain starts a little slow working. And it happens very naturally. Why? Because there's oxygen around is less. Your brain gets less oxygen and therefore it thinks less. That situation is called as anoxia. Again, you people are bio people. Remember, it's really, really important. It's really important. Anoxia. Solubility of gases in liquids decreases with rise in temperature. Already cleared it out. When dissolved, the gas molecules are present in liquid phase, and the process of dissolution can be considered similar to condensation, and heat is evolved in the process. Remember, heat is evolved in the process. We have learned in the last section that dissolution process involves dynamic equilibrium and thus must follow Lee-Chatelier's principle. So this was the dissolution. is an exothermic process, the solubility should decrease with increase in temperature. Beautiful statement, the summary of the entire topic. The summary itself of the entire topic. Okay. Bala says acute mounting sickness. Absolutely, Bala. Right, sir? Anoxia. Now, how do we take up the next thing, which is called as a vapor pressure of liquid solutions. Now, what was vapor pressure? So, the pressure exerted by vapor on the surface, right? The pressure exerted by the vapor on the surface. How it says the solute can be gas, liquid. Let us consider a binary solution. So, binary solution means two components with two volatile liquids. Volatile liquids means what is volatile? That forms vapor. That forms vapor. All right. Let the total vapor pressure at this stage be P total and P1, P2 be the partial pressures. Hardly matters, sir. We talk about Raoult's law now, which states that for a solution, the partial pressure is proportional to the mole fraction. I remember that yesterday what we had done. Pressure is proportional to chi A. Pressure of A is proportional to chi A. Similarly, any volatile component, any volatile component, pressure proportional to any volatile component, comma, pressure proportional to mole fraction. Again, for a volatile component. Why? Because for a non-volatile component, there is no vapor pressure. Remember, for a non-volatile component, no vapor pressure. For a non-volatile component, your vapor pressure is zero. Your vapor pressure is zero. Very, very important statement and very, very important concept also. Right? This is what we did yesterday. My total pressure will be P1 plus P2, P1A chi naught, P1B chi B, and all that thing. And this is going to be my graph. Yes, we talked about that the forces should be similar, and then how we take it as Raoult's law, as special case of Henry's law done. This is nothing. Now, how we do it? That if ideal and non-ideal solution. This is the next important topic because that is where we take the deviation from. So ideal and non-ideal solution, how are they defined? When we say ideal solution, delta H mixing is 0, delta V mixing is 0. Means the forces of yours and the forces of mine are same. Means for a binary ideal solution, the forces of each liquid, the forces of each component are similar. The forces of each component are similar. The forces of each component are similar. But how does it mean? How does it gather? How we have to do it is by the two terms which is called as delta H mixing and delta V mixing. Delta H mixing means neither heat is released nor it is required. Neither endo nor exo. Neither endothermic nor exothermic. I need to figure out where did that undo. Oh, it is here. I get it now. Nor exothermic. Right? And V mixing means 10 plus 10 is 20. We will talk about it when we talk about this one. What should we call it as? Deviation of Raoult's law. Then we have something, there are two conditions that it means no heat is absorbed or evolved when the components are mixed. Also, the volume of solution would be equal. The volume of solution would be equal to the sum of the individual components. 10 plus 10 is 20, right? Even you had no attraction, even I had no attraction. So when we both joined, even then when we have no attraction, then it is called as an ideal solution. AA, BB and AB forces should be of same nature. Remember, the forces of each component are same. What we should write here, AA, BB and AB forces should be similar. AA, BB and AB forces should be similar. Now it says at molecular level, ideal behavior can be explained by considering two components A and B in pure. Now that is where it comes in, sir. That is where it comes in. What I'm talking about, the intermolecular forces between AA, BB are nearly equal to those between AB. Then you form what is called as the ideal solution. You form what is called as the ideal solution. Very, very, very important concept. Very, very, very important concept. Right? Okay. And now we have the example also. Say for example, mixture of N-hexane and N-heptane. Both are your this one normal alkanes, no force of attraction. Even their box combination box will have nil. Yes. Now we have non-ideal. Obviously, there's going to be something where AB will be stronger or AA will be stronger. That type of concept is called as non-ideal solution. Two types of deviations which we talked about in terms of pre-wedding. There was a word I used in the yesterday's class, pre-wedding. So it's not a pre-wedding per se. I corrected that yesterday also. Not a pre-wedding, but it's something like, your bond is stronger pre-wedding that way. Your bond is stronger before the reaction. That way I was relating it to it. But anyways, nevertheless, remember guys, there are two types of deviation. One is called as positive and the other one is called as negative. I told you yesterday as well, when I say positive deviation, I always mean to say, whenever I say positive deviation, I always mean to say that whenever I say positive deviation, what should I say? Sir, my delta H mixing will be positive. Greater than 0 means will be positive. And delta V mixing also will be greater than 0, which also means positive. And that is why the deviation's name is positive. Now, when will my delta H will be greater than 0? Delta H positive means it is gonna be an endothermic reaction. And when it will be endo, so when it will be endo, so when pre-reaction I am stronger. Relation of a pre-wedding. Sir, pre-wedding I was stronger, sir. My bachelor life was good, sir. My bachelor life was good. Sir, now my life is moe moe. The song that is trending right now, right? Moe moe. All that things happening around. So endo means I have to break few bonds earlier that I had made, and that is why how we call it as my AA or BB forces are stronger than AB forces, and that is why you are an endothermic reaction, because I have to give energy to break your initial bonds. Energy is required to break the initial bonds. Means energy required to break the initial bonds. Right, sir? Right, sir. Jai Hind, sir. Okay, sir. Right, boss? Very good. Quickly moving forward, we have the cause for these deviations lie in the nature of interaction. AB interactions are weaker. Now we are coming to this. AB are weaker. AB are weaker. In this case, intermolecular attractive forces are weaker. This means that in will find it easier to escape. This will increase the vapor pressure and result in positive deviation. Is what I also talked about, is in positive deviation. Mixtures of ethanol and acetone. Why ethanol and acetone? Sir, because earlier ethanol and acetone, they have H bonding, behave in this manner because pure ethanol has H bonding. Pure ethanol has H bonding, whereas this mixture does not have it as such. This mixture does not have it as such. Alright. In case of negative deviation, the intermolecular forces between AA and BB, very very important, attractive forces between are weaker than those of the product, and leads to decrease in the vapor pressure resulting in negative deviation. Alright, quickly we proceed forward. This decreases the escaping tendency for each component and consequently the vapor decreases. Now there's a beautiful word which is called as azeotrops. And what are azeotrops? So they are constant boiling mixtures. They are constant boiling mixtures. Why? Because this is also important. They are constant boiling mixtures, which are binary mixtures having the same composition in liquid and vapor phase and boil at a constant temperature. In such cases, it is not possible to separate the components. There are two types of isotrops, minimum and maximum boiling, minimum boiling and maximum boiling. Positive deviation is minimum boiling. That's it, what you should remember. Positive deviation is minimum boiling azeotrop. And not in quality. Right? Yes. Then what we have here, we move forward. The first property that you guys come across is relative lowering in vapor pressure. The first property that you come across is relative lowering in vapor pressure. Why? Because, sir, I was adding a non-volatile solute and that was creating all the problem. Right? So what do we say? We have learnt in section the vapor pressure is less than that of the pure solvent. Why? Because Raoult established that the lowering depends on the concentration of the solute particles. The equation given establishes this. So when, sir, it's P1 not chi1. So what is the real dip? What is the real dip, I should say? Delta P is P1 not minus P1. Why? Because, sir, it was earlier also it was pure, but now it is contributing lesser. Right? Knowing that chi2 is 1 minus chi1, in this solution we have it can be written as you see here. This is relative lowering. This concept is called as relative lowering of vapor pressure. Right? Relative lowering of vapor pressure. Quickly we proceed here, and is equal to chi2, which means mole fraction of the non-volatile solute. Non-volatile component. Right? Quickly, just read it once. Quickly, 2 minutes and you read it quick. All right. So it is done. Reading part is done. Reading part is done. Where is the chat box? Done, sir. Very good. Very, very good. Come on. Happy to see that reply. Very good, sir. Then we come across something which is called as mole fraction of the non-volatile component we had discussed yesterday. And what is mole fraction? Mole fraction is my moles upon total moles. So when I say mole fraction of chi2, 2, which is chi2 is n2 upon n1 plus n2, and then generally what happens is n2 is much less than n1, so we make it n2 by n1, but that is only for dilute solutions. That is only for dilute solutions. Okay, that is only for dilute solution. Right? Only for dilute solution. We now move forward, and the second colligative property is elevation of boiling point. What was that? Sir, my boiling point increases due to addition of non-volatile solute. What was the formula that we captivated yesterday? Delta TB was KB into M. Delta TB was KB into M. Sorted, sir. Delta TB was KB into M. What it says, water boils at 100 degree. We have also learnt in the last section that vapor pressure of the solvent decreases in the presence of non-volatile solute. Vapor pressure decreases in the presence of non-volatile solute. Right? So then what do we have? For example, the vapor pressure is 1.013 bar at 373. In order to that, above the boiling temperature, thus the boiling point of a solution is always higher in which the solution is prepared. Similarly to the lowering of vapor pressure, elevation of boiling point also depends on the number of solute particles. It's a colligative property, sir. And then we see delta TB. Delta TB is TB minus TB naught. What is a change in the boiling point is called as the elevation. My boiling point increases, right? My boiling point increases. Delta TB is KB into M is where we talk about it. M is called as a bleoscopic constant. I think the spelling yesterday was absolutely right. Molar elevation constant or a bulioscopic constant, right? Then molarity. Yes, substituting the value molality in equation this is, and we get what we wrote yesterday, the formula. It's just that the molality is value they have captured here in this formula. Nothing else. The third colligative property is depression of the freezing point. And when we say depression of the freezing point, we talk about delta TF. For the same reason, my freezing point decreases because of the presence of a non-volatile solute. The lowering of the vapor pressure causes lowering. See, my vapor pressure lowers, causes the lowering of freezing point compared to that of the pure solvent. Right? We know that the freezing point of a substance, a solid phase, is in dynamic equilibrium. Thus, the freezing point may be defined as the temperature at which very peculiar line, very important line per se for this chapter. The freezing point may be defined as the temperature at which the vapor pressure of the substance in the liquid phase is equal to its vapor pressure in the solid phase. Very important. A solution will freeze when its vapor pressure equals the vapor pressure of the pure solid. According to Raoult's law, it decreases and therefore the freezing point decreases. Depression in the freezing point. Similarly, we have delta TF is Kf into M. We call it as cryoscopic constant and then we put on this formula. Remember, my Kf and Kb are constants, but still they are dependent on the temperatures. Kf and Kb are temperature dependent phenomena. Kf and Kb are temperature dependent, are gas constants and molar mass of the solvent, and Tf and Tb denote the freezing point and the boiling point. Further, delta H fusion, enthalpy, and vaporization represent the enthalpies of the fusion and vapor. Very, very important stuff. This could be a source of question in NEET 2024. Right? So please don't leak the entire paper. I don't know, these are important questions. That is what I'm telling you. Last but not the least is the property which is called as osmotic pressure. This is the last colligative property that is there. There are many phenomena which we observe in nature. For example, raw mangoes, when they put in water, they absorb and get swollen. All these substances are bound by the membranes. We know what is osmosis. Osmosis is transfer of material through a semi-permeable membrane. When we talk about osmosis, we always talk about transfer through a semi-permeable membrane. Audio gone. Why? Can you not hear me? Hello? Audio gone. Why? Can you not hear me? Am I audible, right? Hello? It's perfectly fine here. Hello. Okay. Okay, I think Sri Sai, you need to just refresh this video once because to me the audio is absolutely clear, Baba. And in front of me, okay, so let me check mine, right? Better because in front of me that I can see it on the laptop also that the audio range is absolutely right. And anyways, tomorrow onwards we'll have a mic here that will also be better. But today the audio is clear. To be honest, check at your point. If there is still any problem, we can see. Now, transfer through a semi-permeable membrane, obviously from higher concentration to lower concentration. How it goes is small solvent particles. The process is called as osmosis. We will not control that now. The flow will continue till the equilibrium is attained. The flow of the solvent from its side to solution side across a semi-permeable membrane can be stopped if extra pressure is applied on the solution. So that is the definition of the osmotic pressure that just stops the flow of solvent is called as osmotic pressure. The pressure required to stop osmosis is called as osmotic pressure. Osmotic pressure of osmotic pressure, where are we? Okay. The osmotic pressure of a solution is the excess pressure that must be applied to a solution to prevent osmosis. That is stop the passage of solvent molecules through a semi-permeable membrane. That is, I want to stop the process, and the pressure that I need to apply is called as osmotic pressure. Formula is what all of us know, which is pi equals to CRT. Right? Generally, we call C as a concentration, which is molarity. Right? And then they put the formula of molarity, which is weight upon volume. Right? Quickly, we proceed forward. Two solutions having same osmotic pressure we discussed yesterday also. Having same osmotic pressure is called as isotonic solution. When such solutions are separated by semi-permeable membrane, no osmosis occurs. For example, the osmotic pressure associated with the fluid inside the blood cell, it is very, very important example in terms of biology. Since we are preparing for NEET exam, this becomes really important. Fluid inside, fluid inside the blood cell is equivalent to that of 0.9% NaCl solution called normal saline solution, and it is safe to inject intravenously. What is intravenous? Inside the veins. Then there are many injections that are put inside the veins. So are you going to do question sessions also? Tomorrow we will have a complete question solving session from solutions chapter itself, Shri Sai. Yes, we will have for each chapter day 1 theory, day 2 NCRT, day 3 questions. Thorough. Right? Good. On the other hand, if we place the cells in a solution containing more than this, water will flow out of the cells. Such a solution is called as hypertonic, then hypotonic, and that is how isotonic means same osmotic pressure. Right? And then you get the topic, what we say, the phenomena mentioned in the beginning can be explained on the basis of phimosis. Then it says the resulting pulpiness of the swelling is called as edema. Concept is important then. What it says is uh, water will move into them through osmosis. When placed in water containing less than 0.9%, blood cells swell due to flow of water in them. People taking a lot of salt or salty food. Very, very important concept. Again, you will be the future doctor, so you should always know this. What it says is that the people taking a lot of salt or salty diets experience water retention and intercellular spaces because of osmosis, and therefore swelling happens, which is called as edema. Water movement from soil into the plant roots and subsequently into upper portion is also osmosis. Then we have reverse osmosis in water purification, is what we already know. And last but not the least topic is abnormal molar masses, which is due to dissociation or association, also called as Van 't Hoff factor, right? Also called as Van 't Hoff factor. Quickly we do that because 6 p.m. I understand you have your bio class also, but still we have time, not to worry about it. See, we expect 1 mole of K plus and 1 mole of Cl minus. This is what he's talking about, that 1 mole of KCl should mean 1 mole each of K plus and Cl minus. And therefore what we are calculating it is not right. And we have the concept of I, which is called as Van 't Hoff factor, normal upon abnormal. This is really important. Observed upon calculated. May note that this formula, if you do not know, there are high chances that you miss on it. I'm telling you that you miss on it. Right? So it's gonna be I, which is Van 't Hoff, is normal upon abnormal, which is observed upon calculated. Observed, which you know. Calculated, which you actually calculate. Right? Very important here. Abnormal molar mass is the experimentally determined molar mass. See, abnormal is experimentally determined. And then colligative properties are obtained by assuming that the non-volatile solute is neither associated nor dissociated. In case of association, value of I told you yesterday, when we say association, I has to be less than 1, and when we say dissociation, I has to be more than 1. Right? For example, the value of I is close to 2, while for ethanol it is going to be close to 1. Including the Van 't Hoff factor, here when we have to summarize the colligative properties, quickly once we do that, it was P1 naught minus P1 upon P1 naught is now I chi B, chi 2 I should say, I am telling 1, 2. Then we have delta TB is I kbm Everywhere we can put I. Delta TF is IKFM, and then pi equals ICRT. ICRT. Alright, ICRT. Very, very important. This is a table that talks about NaCl. We all know that it breaks down to 2. So it's 2. KCl we know, K plus and Cl minus. MgSO4, Mg2 plus, SO4 2 minus, again 2. And then K2SO4, yesterday I had covered in the text, 2K plus and 1SO4 2 minus. This is how we calculate I. And finally, this chapter goes over. And finally, this chapter goes over. Well, within the timelines, we could complete that quickly. We have 5 minutes. We can read the summary also. A solution is a homogeneous mixture. Solutions are classified solid, liquid, gaseous solutions. The concentration is expressed in mole fraction, molality, and in percentages. Dissolution of a gas is governed by Henry's law. Right? According to which, at a given time, the solubility of a gas in a liquid is directly proportional to the partial pressure. Law is captured again. We can underline it here also because summary is very important. The solubility of a gas is partial pressure. The vapor pressure of the solvent is lowered by the presence of a non-volatile solute. Already we know that. Relative lowering of vapor pressure is equal to the mole fraction of the non-volatile component. Very, very important. P total is P1 chi naught, P2 chi naught. Then we have P2 naught chi A, P2 chi B. Solutions which obey Raoult's law are called as ideal solution, do not obey Raoult's law, non-ideal solution. Two types of deviations, which is called as positive and negative deviations, right? Next thing that we have to show is azeotrophs arise due to very large deviations. Azeotrophs, two type, minimum and minimum boiling and maximum boiling, right? All right, then we have the properties of solutions which depend on the number of solute particles and are independent of their chemical identity. I believe in quantity and not in quality. I believe in quantity is the most important thing. These are lowering of vapor pressure, which is relative lowering of vapor pressure, lowering of vapor pressure, elevation in boiling point, depression in freezing point, and osmotic pressure. The process of osmosis can be reversed if a pressure higher than the osmotic pressure. Colligative properties have been used to determine the molar mass of the solute. Solutes which dissociate in solution exhibit molar mass lower than your. This is important. Why? Because I has the formula. Why? Because we have a formula of I that talks about normal upon abnormal atomic mass. Right? Normal mass upon abnormal mass. So for example, if I'm talking about dissociation, I is greater than 1. If I'm talking about dissociation, I is greater than 1. And if I is greater than 1, it means my abnormal, my abnormal is less than the normal. It means my abnormal mass is less than the normal mass, which eventually it is writing in the text also, saying that mass lower than the actual molar mass and those which associate show higher molar mass. So which dissociate will exhibit molar mass lower than the actual molar mass, right? Quantitatively, the extent to which a solute is dissociated can be expressed by Van 't Hoff factor I. This factor has been defined as the ratio of normal to abnormal, as the ratio of observed to the calculated colligative proverb. I told you this formula that is captured on the last page of the NCRT, which is observed upon calculated, is something which you should always remember. There are straightforward questions to it in NEET previous year questions, and it forms a very important concept as well. Right? Right. So this is how the summary of this chapter remains. A very, very easy, a very interesting chapter. But yes, it could actually give you 8 marks. Remember, 8 good marks of solutions. Right? Please go through yesterday's video and today's video as well to get a complete story behind what is called as solutions and to score 8 marks in your NEET attempt, be it 24 and be it 25. Right? All the best for your biology session. Take care and God bless you. Bye bye.